Good day, ladies and gentlemen. I am Sauradeep Sarkar, your host for today's webinar. Thank you for standing by and welcome to the Esri India webinar on Modeling Smart Cities with Esri CityEngine and ArcGIS. The speakers for today's webinar are Narinder Thapar and Vishal Chitroda. Narinder is General Manager at Esri India. He has over 24 years of experience in GIS industry and has worked extensively helping customers with large-scale complex enterprises GIS implementations. Vishal is a pre-sales lead and has more than 4 years of experience in GIS industry. He has good experience working across the entire spectrum on Esri technologies with a specialization in 3D and CityEngine. Narinder and Vishal will share their experience on how planners and designers can use CityEngine to create highly realistic 3D urban landscapes from existing GIS data and leverage analytics capabilities for ArcGIS to streamline the design possibilities. So for the duration of presentation, all participants' line will be in listen-only mode. We'll then have a panel of Esri India experts from other industries and technology areas on call to answer any queries you may have. We will have the Q&A session post the presentation. So meanwhile, if you have any questions, you may also send them across to the panelist using the chat window on the right-hand side of your console. Now, without any further delay, I would like to hand over the proceedings to Mr. Narinder Thapar from Esri India. Thank you, and over to you, sir.
Good morning, ladies and gentlemen. I welcome you to the Esri India webinar series 2015. Today's webinar is on modeling smart cities with Esri, CityEngine and ArcGIS. This is the first webinar we are doing in this particular domain. Over a period of time, I would say next few months, we'll be doing a series of seminars to discuss this entire subject more in detail. Today's seminar will focus on CityEngine and ArcGIS, and along with me will be my colleague Vishal Chitroda. Now I will take you through to the brief agenda which has been outlined for today's webinar. We are basically going to be talking about the role of GIS in smart cities, discussing some of the global references. We'll talk about geo-design as a key building block for a city design. We'll talk about CityEngine as a technology. We will demonstrate some of the use cases to you, and which will be followed by question and answers, as the moderator has already mentioned that you could send your questions and answers through the chat mode, and which will be consolidated, and we'll be pleased to take your questions towards the end of the session. I'm sure most of you are aware about who we are. You know about Esri India, but it's for the benefit of some of you who might be new to us. Esri India is a joint venture between NIIT Technologies and Esri. Esri stands for Environmental Systems Research Institute. This is a company based in Redlands in California who pioneered the concept of geoprocessing. Esri is a global leader for GIS software technology with our flagship platform called ArcGIS. And we have over 300,000 customers using it worldwide. In the Indian context, most, or rather I would say major national projects in India, they use Esri as a core GIS technology for the mission programs. We know India's population has been growing at an alarming rate, and which also brings in a lot of problems related to pollution, unchecked migration to our cities. Last few weeks, we've also been hearing about Delhi being the world's most polluted city. So there's a lot of pressure which is there on the Indian cities. Based on the report by McKinsey and data released by the ministry, in the year 2030, we'll have 590 million people living in the cities. Today we have around 53 cities which are a million plus cities population, and by 2030 these will increase to 87. And along with that, there's a lot of infrastructure that is going to get developed. This could be in terms of metros, this could be in terms of subways, roads, and huge amount of investments are going to happen in this particular area, which will also lead to economic growth. The challenge before us is to create cities of the future. They are able to meet the needs of, the demands of ever-growing population without compromising on the sustainability and energy efficiency. India has been in dire need of smart and cost-effective solutions. And the government has come up with a plan for creating 100 smart cities, which will be sustainable, which will have a better design, which will provide better living conditions to the citizens, which will have there will be a great amount of balance between the socio and the economic conditions, and providing a governance platform. They will enable policy framework. So all such initiatives from the government will lead to creation of sustainable smart cities. When we talk about cities, or we talk about smart cities, we are basically talking about new cities to be created or existing cities to be retrofitted or redeveloped or pan-city developed. So the concept of greenfield and brownfield cities comes in. But even if we look at creating a new city, what comes to our mind is, where is it that I'm going to locate my city? Which area do I see, there is development happening? Which areas do I need to concentrate on? Or if I want to do a zonation for my city based on certain factors, how do I do the zonation? How do I comply with the regulatory framework? It could be the environmental compliance or other legal compliances. Or some new land to be acquired. What's the valuation? Which is the land which I need to acquire to create a greenfield city? What's the right valuation for that land? So likewise, when we look at such questions coming to our mind, what's fundamental or what's common to this is the location. So location actually is pervasive. And GIS, we know, is a backbone which helps planners do end-to-end planning. And so GIS becomes a critical component of this. It's not just about technology. GIS is also not about a hardware or a software. It's about data which comes from multiple sources. This data could be related to, it could be satellite imageries, it could be your existing master plans. This data could be the socio-economic data coming from census or different other data sources. Then we talk about designs or models which we follow. There are solutions. We talk about people. People play a very, very important role in this because technology is an enabler. But what's important is the domain knowledge. That's what comes from people. That's what comes from specialists. So that's where technology basically enables that. And it also enables the connectivity between different individuals, different organizations, brings in a lot of synergy and collaboration. And there are processes which have to be followed. So if we look at it, GIS basically plays a key role in meshing everything together and providing you a technology platform. And if you look at it, GIS basically offers you a comprehensive approach where we talk about data coming in from, different disciplines. It talks about collaboration. As I said, when we talk about even creating a master plan cannot just be can't be created in a silo. We talk about integration, we talk about collaboration with different participating organizations. We talk about collaboration with different stakeholders. So that's where GIS helps you do that intuitively over maps. It also allows complete transparency, when it comes to sharing information. So the way it works here is when you create GIS-based maps or you create GIS-based master plans or you create GIS-based plans or any such information, you basically have a common operating picture throughout the hierarchy of the organization. Here, from an executive level or a chief executive level or from the head of the department down to the working executive within the organization, which is government to government, or from the government to an individual citizen where it comes to publishing, say, the master plans and then inviting public suggestions on that, or, publishing gadgets and things like that and asking for public suggestions. It provides you a common operating picture. It's not that it's different for some people and it's different for public. So GIS basically gives you a same platform. And also when we are doing our planning, we know what factors we have taken into consideration. So when we do the planning and design, so we take certain factors into consideration. So we know the kind of risk we are working on. So it helps you manage your risk better. So GIS, again, as I said, to reiterate, it plays a key role. And to look at it, I would say ArcGIS is a platform for cities. I just talked about collaboration. So when we talk about cities, it's not just about one kind of information or one particular data sets. When we talk about smart cities per se, there's a lot of component of ICT, information and communication technologies, which will come into the play. We're talking about sensors, we're talking about networks, we're talking about lots of data which is going to be flowing in. We're talking about Internet of Things. There's a lot of thematic information, a lot of topographical information, satellite imagery is coming in, information related to the utilities, which could be your water distribution networks, it could be the power utilities or the gas utilities. So different kind of utilities or 3D visualization of the buildings. So all this forms the data platform. And then what ArcGIS provides you is a common framework. It provides you a platform which will help you collaborate, access, share information, give you, inbuilt, out-of-the-box applications or templates to create apps, which will basically bring stakeholders from utilities, infrastructure, governance, transportation, healthcare together. So what we are basically talking about here is we are talking about creating a city GIS hub. So we are saying there's a hub, GIS hub being created at a city level where you have different stakeholding departments. You have the administrators, which is the government in this case, or the municipal corporations, or the urban planning department, the town planning department, or other related departments. Could be utilities, will be the stakeholders in a smart city scenario. It could be utilities, it will be healthcare, it will be transportation network. So all these people they are the stakeholders which contribute to the city GIS hub, and through a common platform, you're also sharing this information. This could be on a G2G, which is government to government for administration and day-to-day works for operational works, and it could be government to citizen, what you deem fit or what the cities deem fit to be shared. There are a number of examples, there are a number of case studies, where this has been used, and this is, the information being shared very effectively, which ultimately gives a better living experience to its citizens. And that's what the objective from the government is. Now, if we look at it, many of the cities globally, I would just name some of them, have been using GIS technology, they've used ArcGIS. The case in point is the Jurong Lake District, which is being developed by the Urban Redevelopment Authority of Singapore, or Masdar City in Abu Dhabi, Lavasa in India, Gift City or Honolulu. What's common to each one of this is basically that these agencies have used GIS from the very, very beginning, and they've used GIS very effectively. This is one. And second thing is they have also involved different stakeholders, at the planning stage. They have collaborated, and that is what has led to the successful implementation of GIS. And these cities have been planned to be sustainable and to be highly energy efficient with minimal carbon footprints if you look at it. Now, if you look at, there's a concept of geo-design that has been critical element in the overall design process. And these are good examples in place to look at. Now, I'll talk a little bit on geo-design. So geo-design basically provides a design framework and supporting technologies to leverage geographic information, resulting in design that closely follows natural systems. So geo-design is a concept which has been used by Esri, and this concept has been used to create two major tools to say. The first one is called GeoPlanner. GeoPlanner, which is a 2D web services based geo-design tool that allows data to be analyzed, to be designed on top of, to be evaluated quickly, and then the decisions can be made when we look at alternative plans using the workflow which is provided with this tool. So that's about GeoPlanner. And this workflow is also being supported on the desktop product of CityEngine. So desktop product of CityEngine also follows the principle of geo-design, and this is used for more and more applications of urban design. So what we talked about, even things like, I just shared the example of the Jurong Lake District with you. They have used these tools effectively and very, very efficiently to create master plans for the new areas they are going to build, they are going to develop. So I would simply reinforce that it is not just for the design community, It is a tool and it's going to become pervasive. With this, I will now hand it over to Vishal Chitroda, my colleague, who will give us a deep dive into the CityEngine. He'll talk about how geodesign as a concept has been incorporated in our tools, the tools I just talked about, and he will also take us through some of the case studies, some of the use cases in that. Over to you, Vishal. Thank you.
Yes, thank you, and very good morning to all the viewers. So as Narendra rightly said, geodesign is where we actually analyze, design, evaluate and share the information which we have. Now it comes across two tools. So today we are going to speak on the CityEngine. So CityEngine is more than just a 3D modeling tool. So with this software we can efficiently analyze as well as visualize different modeling which has been done in the process of geodesigning. So CityEngine is 3D modeling and design solution. So it is a standalone desktop application where it comes as an extension to ArcGIS products meant for 3D data generation, planning, design and modeling. So we create 3D cities from 2D GIS data. It is a rule-based modeling software where parametric user interface and various script-based rule mechanism is provided. So we have some powerful work done with CityEngine, not just giving you fast, powerful tools to support your content, but also to transform the way you model your 3D data. So we bring this software as a demonstration in today's webinar. Moving ahead, transforming your 2D GIS data into smart 3D city models. As you could also see, it is a 5-step. It's easy, simple, and it enables users to create, visualize and analyze their 3D data models. Step number 1, as we said, planning is a complex process which involves various stakeholders. So your information in a 2D information model or a geodatabase could be a step number 1. This may include rules such as zoning, other rules, landscape modeling, roads and various other utilities which are planned. Step number 2 is we add a 3D street blocks and parcels. You make use of digital elevation model or the terrain, which gives you your perspective in 3D. What we could also do is we could extrude these buildings in 3D, create roofs or create the structures and street furnitures which are there associated with your 3D modeling. In today's example, we'll just showcase you all these processes one by one. As we go ahead, we go for step number 4, which is for modeling. Now CityEngine has very powerful tools to model and create facade or use your complete facade creation details. Last and the most important, what you could also do is the finished 3D model or the finished 3D city can be shared across the department, across the users, so that we get in a collaborative manner. This can be shared using web scenes. So CityEngine web scenes has a powerful functionality to share your data or your web scenes over web, where various users can give their inputs, and it gives a more collaborative and shared approach. Moving ahead, so CityEngine offers flexible 3D design environment. It supports various industry standard 2D and 3D data formats. You may import and export data from various formats. For example, you may import CAD, Google, ArcGIS formats such as shapefiles or file geodatabase format. This enables users to align themselves into various departments, and you get data across for data designing and analysis phase. So as we say, there would be certain set of rules applied for zoning parameters or streets, and all these things can be actually stored in a data-centric format of geodatabase, which can be further used for visualization, analysis, editing your 3D data, and CityEngine is what it would add in for rule-based 3D modeling. It also provides multiple views for the same data. So I can take these new buildings and change the 3D view from rendered look to a more thematic look, showing a zone by zone visualization of every floor, or even modeling your landscape, enabling different users in the designing and planning process to relate different programmatic demands and different spatial solutions. So as you could see in this particular example, you have 2D footprint, which can be actually used and modeled across as 3D data model. So what it uses is, you have geometry. This can be your simple Esri shape files or file geodatabase. You have attributes such as what is the type of building, what is the zone, what is the other parameters set up, like is it a residential apartment, is it a commercial apartment, what should be the building height, what are the setback parameters provided, and it combines themselves with rules. So these are CGA rules, as we say, to bring in first your geometry, either in GIS or CAD format. When using GIS, we can take advantage of shape data to further automate the modeling. Then we apply a rule. This is a combination of existing 3D models and textures together with a simple scripted framework called CGA, that is computer generated architecture. These generated models can interactively have more complex 3D modeling from a basic forms that resembles something more close to the reality. So as we say, we create rule-based 3D cities. And the last and the foremost, which I would also like to showcase in just coming demo, is we may share this as web scenes. So web scenes can also be shared using ArcGIS desktop 3D through ArcScene or ArcGlobe. We make use of ArcGIS Online to share my web scenes across the departments. So sharing through a URL in a 3D browser is faster, it is easy to use, and it is modern GUI and graphics are enabled. You can share your content, packages, web maps, web layers, and you may even share your 3D web scenes with the latest release of ArcGIS 10.3 onwards. Apps have become more effective, and sharing your authoritative content, we are extending ArcGIS data model to include 3D web scene services. You can almost think this type of sharing very similar to sharing a map service or sharing 2D content. Now you can also share your 3D content and services using 3D web scenes. These services will not only enable you to share your data, but also have a more collaborative approach. In these two examples, you could see you can have a side-by-side approach of before and after a redevelopment scenario. This gives users not only the visual help, but it also helps them to analyze their design patterns. Design is a very complex process where there are so many things which have to be taken care of. GIS would give a very handy tool to actually visualize and analyze various different processes. For example, we come up with 3 different design concepts. A building to be modeled in a particular way. So we create plan 1 or plan 2. CityEngine would not only model your 3D data, but also help you to visualize and analyze or compare them side by side. Going ahead, we would like to demonstrate CityEngine. Yes, then as users could see, this is a desktop based software for 3D design and modeling. Taking a smaller area of interest where you may use base maps, or you may also use aerial photographs as your basis. Now you may model your data as per thematically representing different types of buildings. As you could see here, the color coding from yellow to blue or to violet shows different type of usages of these particular buildings. Let us select any one of these. So selection, this particular case we have used and shared across Esri websites. Users may make use of various demonstration tutorials and rule templates provided through Esri sites. So depending upon the usage, it actually color codes itself on the fly, and it changes itself in the way we want to model this particular information. So if I change this usage to a residential type, it changes itself or aligns itself back to yellow systems. So as you see, the planners in the process of geodesign can not only thematically visualize their data in 3D, but they could also create a facade based or more textured based approach. So if we want to create the same textured approach over these particular model buildings, is what I could do is I could apply textures or I could apply rules on my model buildings. This creates a complete 3D view of my buildings, that I could model my buildings using simple rules. Now CityEngine would not only help you to model your data, but it also has various set of functionalities that you can control the scene light conditions. This helps users to analyze or to understand what would be the effect of shadows on your particular buildings. So as you see, if we concentrate on this particular building, just helping ourselves to understand what would be the effect of shadows or what shadow effect this particular building would have, and you may change the usage to a textured to a non-textured way. So in a shaded way, it would give you the overall approach that how I'm trying to model my buildings, and you also can have a textured approach. Going ahead, on creation of these particular rules, this would be as easy. Model. Selecting a model, CityEngine is a design tool which not only helps you but you also have some aspects like changing the height. It models itself on the fly. Going one step ahead, you may also include about modeling your streets along with your buildings. So as we could see, we may model our streets even up to finite details about adding up a street light, a signal, or even defining about street width and the footpath along with that. Creation of streets, it aligns itself to the rule applied to my particular street creation. Now let us consider this particular case. So here, as we could see on a map also, posed, and we can just create a new road from my existing one. So as I may start, it has which helps you create your particular road information. So as you could see, as I am trying to draw myself, the rule automatically applies itself to my particular streets. Users may see the type of usage which happens towards the end. Since it is a turn, it aligns itself to a turning radius. If it is a junction, it aligns itself to a crossing or a junction. Users may make use of these tools not only to visualize but to also create a more realistic picture. Now every road would also have your attributes along with them. You may want to change a few. So selecting any of the junctions, we get a detailed attribute about everything. You may make use of these particular rules shared through modern street examples. You just have to go into Esri.com CityEngine and you may get these templates and examples. You may make use of modern street examples to model your streets. Going ahead, now there would be an open plot where we think there is a process of redevelopment to be thought of. In this particular case, we may draw ourselves or we may create an imaginary scenario where a redevelopment process is about to happen. So on an open ground scenario, so I just take this as an example case. Users get the functionality to not only add the data from CAD as well as GIS formats. CityEngine would also enable them to create the data or the create 3D models right inside CityEngine. So here is, if I may start drawing my particular plots. So this one is just to demonstrate that if I am trying to create of my own, these particular plots, what they have is they can manually design or manually model this thing into a 3D model, or they may use a ready-made tool, or they may use various rule samples provided to actually transform themselves into a more 3D manner. So if you could see any of the wizard city rules, and I just need to drag and drop a rule on top of my plot. The moment it is done, it would ask you for the type of alignment of this particular road. So I may align it as an open space, and I may model trees or I may not. Going ahead, we can create one more plot just right besides that. This plot could be aligned to different type of buildings. So going ahead to the most tutorial which you may use, a building.cga rule. I apply on this particular building. It models my building on the fly. Now here you have controls over deciding upon the floors, floor height as well as overall building height. So selecting my model, I get functionalities such as to control over my floor height or overall control over my height of the building. So in the process of geo-designing, when users are designing across various complex processes, depending upon the floor space index which they are provided upon or the number of floors which they are permitted to use, they may model their 3D on the fly, and they have these controls to actually visualize their data and visualize their models in a more realistic manner. Going ahead, as Narendra also said, there's a heavy demand of smart cities, and the city needs to be sustainable, needs to think of various cases. So not only about streets and the buildings, we may also model in for something which could be planned like a rapid metro corridor system or a rapid bus route transit system. So this helps in a strong, rapid, faster and a sustainable transport mechanism which helps the citizens to commute and various other things. What we could do in here is, we may model ourselves and create a more of a transit system mechanism. So as I could see, I may go in ahead in modeling my particular metro or modeling my particular transit system. So I just we may create a complete elevated metro transit system. And we may also model that what would be the effects of upcoming stations on my existing landscape. So as there would be demand across various cities across India that we model ourselves for bus rapid transit system or a metro system, and we may also actually plan it using various GIS tools which would be helpful in planning, understanding the utility or the transport network. But not only that, we may also model them and have their visual analysis as well as interpretation. Now this would not restrict itself to modeling man-made scenarios about buildings or roads or metro systems. We may also model natural or more scenarios, such as if I go ahead and take you to a particular landscape. So this landscape would not only have this green cover across the city, but it also we can model them using various trees and other concepts. Now take for example this particular landscape. If I apply some landscape applications on top of these buildings, it aligns itself and creates a 3D model. You may control your scene light parameters and visualize your models accordingly. So going ahead, CityEngine would not only model your buildings and streets, we have also rules created for various trees and more natural environments. So if I remove this particular mesh again and see to the base map, for a green cover which is available, we may also model a landscape showcasing various trees and green cover. We may also go ahead and model a natural water body or a lake. So going to the other part of my particular area of interest. So if there is a lake, river or a natural system which can also be modeled and showcased as your complete 3D model. So if we switch on my particular lake case, it models itself as a lake. Now there would be scenarios where there is a close and tight integration between natural and the man-made environment, and we need to model both of them simultaneously. This would not only restrict ourselves in modeling this, but also comparing and analyzing two different scenarios. So going back to our redevelopment scenario, in a particular case where planners are planning either to go ahead with a certain type of zoning and designing process, or to go ahead with a different type of zoning and designing process. This helps us create different types of footprints and different types of data altogether. One small example. Selecting a particular plot or a building and changing it according to different zones which could be available. I may change them straight away to a residential, or we may go ahead and just save them as a high-rise building. So the CityEngine would not only model themselves, but on the fly it would give you visual as well as analytical interpretation. One more example we could see of different things which can be done in a redevelopment scenario through a web scene. CityEngine web scenes can be created and shared across in a web format. Web scenes are highly useful and essential. So using a web scene, you may actually share and model your data. So I would create a web scene and we may just go ahead and look in what all can be done and shared. So you can share your content as packages, web maps across the layers with the latest release of ArcGIS 10.3. We can almost think of sharing these particular things as a web scene or sharing it in various other formats. Now ArcGIS is tightly interoperable with various industry standards 2D as well as 3D formats. Sharing this across would enable the users to actually not only show their particular work to their colleagues, but also take inputs and in the process of geodesign where they use data, analyze, design and evaluate the process. This can be an additional or for very important tool in case of decision making. So sharing these particular things, we may export this and look at the various formats which are supported across CityEngine. It can be shared across as 2D and 3D industry standard formats. It can be taken ahead back to Esri file geodatabase where I can store my entire geodesign models. Can be shared across through other industry standards like Wavefront, Autodesk, and it can be shared as a CityEngine web scene. So sharing it as a web scene not only creates but also analyzes it in 3D format. Web scenes can further be shared through ArcGIS Online and users can share across their work with various departments. So for this particular example, we had created a few web scenes. These web scenes can easily be modeled and shared across. So there's a campus which we had modeled here in India. Our campus can also be sought across with details like a hostel building or the administrative building. So opening a web scene would be users can actually open it through ArcGIS Online in an online version. Can also embed these web scenes in your existing applications. So using a web scene viewer. So let's go ahead and see one of the web scenes which I had created. Now a web scene would not only give the users 3D visualization over web, but we may also analyze various aspects. Now consider, for example, these two plots. User can go ahead with two different plans in a complex process of geodesigning where he is designing and modeling two different plans or two different scenarios, where first of the scenario would be my plan 1 and plan 2. So if I change my plan, I could see what could be modeled and how this particular landscape would appear. So users may actually use various plans and see how the landscape would appear over web scenes. This not only gives you a place to actually analyze it, but we can also side by side compare both the plans. So a flicker tool, a simple flicker tool would help the users to compare these two plans. So if I change my rules from a residential to more of a commercial or a office usage, this plot would actually realign itself in a different usage. Showing one more example of our campus which we had modeled. So our campus, we were not only able to model buildings, but we were also able to model trees and model it to the landscape which we had. This example is a modeling for our campus which we had done. And users may share this particular work through web scenes and create a more of a animated model, or they may use their bookmarks to actually go across through various models. So if I switch on my animation here, what the users may see is it takes you across a fly through of your models. And it goes across various departments. One more thing which would be available with your web scenes is you may just have a sunlight effect on your particular cases. Selecting for June, I may see that what would be the effect of light during different parameters. So this not only helps the users to analyze, they use these particular things so that they model the buildings in a way that every building gets maximum sunlight, or every building gets as many sunlight as possible, orienting your building or setting the setback accordingly. So to go ahead and conclude, what we could see is, in the process of complete geodesign concept, we go one by one step, that there is a need to model your 3D cities. We make use of CityEngine as a tool to model these cities, and which further helps you in the process of geodesign as a whole. To summarize this complete aspect, what we have is how to design and model a urban redevelopment scenario, right from proposal 1 or scenario 2, model them both in 3D and make analytical decisions over what would be the effects. Geodesigning using CityEngine, using CityEngine as 3D modeling and designing solution. Sharing your 3D models through web scenes, through online, ArcGIS Online. So transforming your 2D GIS data into smart 3D city models. As we said, Narendra had also discussed some of the global case studies, like various users are using GIS, particularly in geodesigning concept. So that would be from my side. Thank you.
Thank you, Vishal. So we have received some questions through the chat mode. I will read out the questions, and accordingly I will also request my fellow panelists. I will address these to, direct these questions to one of my panelists, and we will try revert to your queries or questions, whatever you asked for. The first question is from Mr. Ajay Chauhan, and he's asking if GeoPlanner tool is an ArcGIS tool, and what's the cost of it. I would put it in two parts. One is whether it's a ArcGIS tool, and second is the cost aspect of it. I will direct this to my colleague to address the part one, to Krishna Rao. And for part two, the cost, I would say, it's a...
You can email us.
Yeah, so for cost, I would request Ajay Chauhan to email his coordinates and a specific query related to this, and we will revert to him on email.
Yeah, Mr. Ajay, you could write to us at info@esriindia.com, so that we could understand your requirement more specifically, and provide the respective price point. So regarding your first question regarding whether it's ArcGIS tool, so Krishna probably will be able to address this.
Krishna.
Yeah, hi. GS GeoPlanner is part of the ArcGIS family. It comes through our cloud model of AGL. Once you have to take the AGL, our ArcGIS online subscription, and purchase this as an additional premium app. This is a premium app additional to the AGL subscription which you have to take in. So that's what and as you know that the ArcGIS online is basically works on the credit model. So there are various levels of subscription levels which you have. So we have to basically subscribe for the starter pack and then subscribe for the GeoPlanner subscription separately.
The next question is from Mr. Raja Mohan. Is only file geodatabase supported or it's enterprise also?
Yeah, currently we support only the file geodatabase and we recommend you to still only go with the file geodatabase. Supporting for the RDBMS is planned in the future releases, but as of now the support is only for the file geodatabase.
The next question is from Pape Gowda, BJ. While creating 2D to 3D data, please let us know if the topographic elevation is taken into consideration, and if so, how do you input the rules? I'll repeat. While creating 2D to 3D data, please let us know if the topographic elevation is taken into consideration, and if so, how do you input the rules? Vishal Chitroda, can you answer this?
Yes, it's a nice question. Yes, CityEngine has capability to include topographic elevation. What we can add as a base map, also as a digital elevation model. So the rules or so the buildings which we are trying to create align themselves to the terrain. So the moment they align themselves to terrain, it involves your terrain undulations and the topographic elevation. So the process in doing this is we may just add digital elevation model or the topographic elevation available with us and align our shapes, our 2D shapes to the elevation model. So this aligns themselves to terrain, and accordingly we may make use of topographic terrain also in our 3D modeling.
Yeah, just to add up what Vishal has already conveyed, I think the question was more onto this: can we take up the parameters from the digital elevation model and put it into the 3D model, which are 3D buildings or something? So we would like to basically know the base height, and that is getting incorporated into the design which you are doing. Now, as of now, we are not picking it up. It is more of a design aspect and display for this, wherein the models which you create get aligned to the 3D model, but we are actually not picking any information from the DEM and incorporating into the design. But yes, I think that is what something can be extended using the CityEngine SDKs which are available separately.
The next question is from Sailesh Pandey. Please tell the examples of Greenfield City where you have implemented both the tools. Krishna?
I think one of the best example is the Masdar city, which we have done it, and the Jurong Lake in Singapore, which is also implementing that.
Correct. ESRI's role in this has been providing the ArcGIS technology, which incorporates geodesign and the CityEngine tools which they have used.
Yeah.
If I want to export the rule-based model developed in CityEngine into CityGML, which is a semantic model supported by OGC, is there any plugin for this?
Yeah.
Krishna?
Yes, Esri has given you, you need to use our separate data interoperability extension, which gives you the tools for importing and exporting the CityGML. As of now, we support only 21 different features. And if any of your model falls within that 21 features, you can import and export to the CityGML. And this data interoperability extension is a separate licensed product which you need to buy it.
The next question is from Balaji P. Is there a possibility to customize the existing model, Krishna?
Yes, there are. You can visit github.com where there are certain CityEngine SDKs available which you can make use of for extending it. But it's not a full-fledged SDK environment as such, but for certain aspects, like you want to change your attributes through a code, or some of those design like automated design on the display, certain of those things are possible. Maybe the GitHub could be the right place where you can search where the CityEngine SDK is made available for the users.
Okay. The next question is, can we import elevation data to CityEngine? Can we create 3D model using CityEngine? I think this has already been answered by Vishal, so he's already answered this. The next question is from Smita Nigam. How the building and environment data can be climate effective through GIS? Krishna.
Yeah, this is, it is not a climate effect as of now. You could have seen one of the web scenes where Vishal has demonstrated that wherein we can just take in incorporate the parameters of the sunlight and the shadow aspects to it. So if you are looking like different seasons, how the model is going to depict. As of now, I don't see any climatic modeling or the scenario on the change, like how a city may look like during winters or summers or other parts it may look like. It is more to the duration of the day and during the sunlight and the shadow aspect is which you incorporated.
Okay. The next question is, can I add custom rules in CityEngine and how easy it is to add? Vishal Chetoda. The question is, can I add, this question is from Lakshmi, and can I add custom rules in CityEngine? How easy it is to add?
Yes, so here what we like to understand is CityEngine, the rules which we create or write are written in Python as .cga format. Custom rules is, yes, if you could write down a Python based rule having Esri libraries with them, or the CityEngine libraries, we may just add in that particular rule inside my main rule file, where you have a provision to start a particular rule inside a bigger rule. So if I create a rule called as building, and you have a custom thing applied to say floor number 5. So applying building rule to your plot and selecting floor number 5 from your selection menu in your inspector would also apply a custom set of rules which you have defined for that particular set of floor to your entire model. So the custom models, yes, if you have written using Python and using Esri libraries through CityEngine, it can be directly incorporated here. Now CityEngine also provides you a parametric, or you could say a rule-based interface, where we write down these particular rules and their behavior. So users need to use CityEngine to write down their own custom models or the themes which they want to incorporate into existing rules, or they want to write down their own rules.
The next question is, how to calculate the building height from 2D map? Is it possible? Vishal Chetoda.
No. Building height calculation can either be done using information, like if you have the attributes that you have building height with you, you may incorporate that. Or there's one more example where if you have something like LIDAR and your DEM, we may use the LIDAR elevation information to actually calculate the building height and align them to individual building features. But
okay.
Direct calculation is not there. We need to calculate using either of the method.
Okay. The next question is, how does underground utilities modeling work in CityEngine?
Yes, we had this particular query coming in earlier also through email to us. We are working on this, and we would just like to get back on this particular case.
I think we are running short of time. We've been able to answer most of the questions. I can take a question or two, but any of these questions which remain unanswered, I would request the participants to write these questions and send it to us at info@esriindia.com. I'll repeat, you can send these questions to info@esriindia.com so that we can revert. I think we're done with the time, so...
And as Narendra said in the very beginning that this is the first webinar in the series, there will be other webinars which will be planned, specifically on the other topics. Will also utilities topic is also planned, so we would be sharing the notifications to you as those events is planned. And meanwhile, if you have any questions, we'll be happy to answer them via our info email ID.
Yeah, and we'll try answer as many questions from you. So request you to forward these questions, because there have been some questions which we are not able to take because the time is over for this webinar. So thank you very much once again for joining us. Looking forward to your continued participation in the forthcoming series as well. Thank you.
Thank you very much, sir. I would like to thank all the participants and the panelists for joining us today. Hope you all have spent a useful time. With this, we conclude the session. Wish you all a great day ahead. Thank you very much.